Welcome back to my discussion on the master chapter. Number of cells collected together is called a storage device, which is battery. The terminals of the second cell. So where is the second cell connected? Observe here, when two resistors were connected in series. My dear students, this is a very important 5-mark questions. Hello students, welcome back to my discussion on the master chapter. This is the 7th session we shall be discussing, and in my today's session I take up the concept of cells in series and cells in parallel, meaning to say, as we have studied earlier something called combination of resistors, something called combination of capacitors. Today we shall deal with the combination of cells. Now, just to have a recapitulation on session 6, where we discussed about cells. We told a cell is a device which converts chemical energy into electrical energy. Using a cell, we drive out electrical energy from chemical composition. And we also told, using a cell, we arrive at least possible energy. My dear students, we discussed the topics of open circuit, closed circuit, and short circuit when it comes to a cell. And we also told that EMF, the so-called electromotive force, is the energy spent by a cell, work done by a cell to move a unit positive charge once completely through a circuit. And internal resistance was the effective opposition offered by a cell, that is, the electrodes together with the electrolytes to the flow of ions. Keeping these things in mind, today we start understanding the two combination of cells. And the first combination that I study is something called as cells in series. So we discuss the combination of cells in series. Hitherto, as we did, in this particular derivation, first I will learn the condition under which two cells are said to be connected in series. I shall define what is an equivalent cell, and finally arrive an expression for equivalent EMF as well as equivalent internal resistance for the combination of given cells. So dear students, now I start discussing something called as cells in series. If you observe the circuit diagram, I have two cells which are connected between the points A and C. So I have considered two cells connected between the points A and C, where E1 is the EMF of the first cell and E2 is the EMF of the second cell. And similarly, R1 is the internal resistance of the first cell and R2 is the internal resistance of the second cell. So I have two cells of respective EMFs E1 and E2, internal resistance R1 and R2 connected between the points A and C. VA is the potential at the point A. VC is the potential at the point C. And I have also considered a point B between them where the potential is VB. Therefore, students, VA potential at the point A, VB potential at the point B, and VC is the potential at the point C. Now let us learn what are the two conditions under which two cells are said to be in series. If you observe the circuit, this is the positive, this is the negative, longer line positive and negative. Observe, students, the positive of one cell is connected to the negative of the other. Again here, positive of one cell is connected to the negative of the other. Therefore, the first condition says the positive of one cell should be connected to the negative of the other cell. So the basic condition for cells to be in series is the positive of one cell is connected to the negative of the second cell. And if you observe, I have not shown I1 is the current flowing through the first cell, or I2 is the current flowing through the second cell. I have simply told I is the current flowing through both the cells. Therefore, the second condition is that same current has to flow through both the given cells. So, my dear students, the basic condition for me to understand cells in series is the positive of one of the cells has to be connected to the negative of the other cell, and the same current should flow through both the cells. Now, as the first part of the calculation, I will calculate the potential difference between the positive and negative terminals of the first cell. My first step of mathematical calculation, I shall calculate the potential difference between the positive and negative terminal of the first cell. Please to observe, the first cell is connected between the points A and B. ನಾನು ಏನು ಮಾಡ್ತಿದ್ದೀನಿ ಇಲ್ಲಿ, ನಾನು ಈ ಫಸ್ಟ್ ಸೆಲ್ ಇದೆಯಲ್ಲ ಅದರ ಪಾಸಿಟಿವ್ ಮತ್ತೆ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ಸ್ ಮಧ್ಯ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಿದ್ದೀನಿ. ಆ್ಯಂಡ್ ನಾನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ದ ಫಸ್ಟ್ ಸೆಲ್ ಈಸ್ ಕನೆಕ್ಟೆಡ್ ಬಿಟ್ವೀನ್ ದ ಪಾಯಿಂಟ್ಸ್ ಎ ಆ್ಯಂಡ್ ಬಿ. No, my dear students, generally potential difference between the two electrodes of the cell is given by V equals E minus I into R. This is the expression for potential difference between the electrodes of a cell. V equals E minus I into R, where E is the EMF of the cell, I current flowing through the cell, and small r is the internal resistance. And keep in mind, I am finding the potential difference between the terminals of the first cell. So I say VAB because the first cell is connected between the 2 points AB equals VA minus VB, potential difference between the points A and B. VAB is VA minus VB. So substituting here, VAB equals EMF of the first cell E1 minus current flowing through the first cell I and the internal resistance of the first cell is R1. So VAB according to this expression is E1 minus IR1, and this is the potential across the terminals of the first cell. Similarly, I will calculate the potential across the terminals of the second cell. So where is the second cell connected? If you observe the circuit, yes sir, second cell is connected between the points B and C. First cell between the points A and B. The second cell between the points B and C. So I will calculate the potential between the points B and C. So similarly it is VBC, which is VB minus VC. Again VBC, EMF of the second cell E2, current flowing through the second cell I, internal resistance of the second cell R2. So this is giving me the potential between the electrodes of the second cell. ನೀವು ಗಮನಿಸಿದ್ರೆ both the cases I have written I, it is not I1 or I2 because the cells are in series. Now what I do is I will replace both the cells by a single cell EQ. It is called equivalent cell. These two cells in series is replaced by a single cell, equivalent cell, whose EMF is E equivalent and the internal resistances are equivalent. So my dear students, what is an equivalent cell? It has to draw the same current as these two cells did under the same potential as we studied in our resistors. So what is happening here? The two cells which were connected in series is replaced by an equivalent cell. This equivalent cell should draw the same current under the same potential. Now, finding the potential difference between the points A and C, that is for this equivalent circuit, we have VAC is VA minus VC. So this is the potential difference for the equivalent circuit. VAC is equal to VA minus VC. This VAC I have split as VA minus VB plus VB minus VC, because there is an intermediate point, point B in this circuit, which also has some potential. So I have written VAC actually as VAB minus VBC. So VAB is VA minus VB plus VB minus VC. I know what is VA, which is I1 minus, so this VA minus VB is E1 minus IR1. VBC is E2 minus IR2. VA minus VB is nothing but VAB, which is E1 minus IR1. VB minus VC is nothing but VBC, which is E2 minus IR2. Putting all EMF terms together, E1 plus V2 minus I, R1 plus R2. So this frames equation 1. Now, for my equivalent cell, comparatively, VAC is E equivalent minus I R equivalent, because we wrote potential is E minus I into R. So we write VAC equals E equivalent minus R equivalent. If I compare equations 1 and 2, E equivalent is E1 plus E2. R equivalent is R1 plus ER2. So the equivalent EMF is the sum of individual EMFs, and equivalent internal resistance is the sum of individual resistances. Observe here, when two resistors were connected in series, in that case, equivalent resistance was still R1 by R2. When two cells are connected in series, equivalent internal resistance is still R1 plus R2. So this establishes the series nature of cells. My dear students, understand grouping of cells, putting a small entities of cells together is what is called a battery. Number of cells collected together is called a storage device, which is battery. Battery is a single entity. Group of cells put together is what is called battery. Now, going to the next combination, what we call as cells in parallel. Condition for two cells to be connected in parallel. Again, definition of equivalent cell and arriving at the expression for equivalent EMF and equivalent resistance when two cells are connected in parallel. My dear students, this is a very important 5-mark questions. Again I say, there are two cells connected in parallel between the points A and C. Two cells connected in parallel between the points A and C. E1 is the EMF of the first cell. E2 is the EMF of the second cell. R1 internal resistance of the first cell. R2 internal resistance of the second cell. Now, how do I understand that they are connected in parallel? Exactly as resistors were connected in parallel. If you observe here, voltage across both the cells should remain the same. The same condition for resistors to be connected in parallel. If two cells are also connected in parallel, the voltage or potential across them remains same. And main current is equal to sum of the individual currents. And therefore we say here two different cells are connected in parallel. Why two different cells? They have different EMF, different internal resistance, and current across the cells gets branched. Therefore, there are two different cells which are connected in parallel. Now, going to the mathematical part, again I will calculate the potential difference across the terminals of the first cell. Potential across the terminals of the first cell. I had the expression for potential V equals E minus I into R. Potential cannot change. Cells are connected in parallel. So V equals E1 minus I1 R1. EMF of the first cell, internal resistance of the first cell. Note students, I have I equals I1 plus I2. So my objective here is to calculate I1 and I2 individually so that I can find the main current. So rearrange here, E1 is brought towards the left hand side, V minus E1 equals minus I1 R1. So getting E1 to the left hand side, V minus E1 equals minus I1 R1. Eliminate minus. So this is E1 minus V is I1 R1, or I1 equals E1 minus V divided by R1. So this is the current flowing through the first cell in terms of EMF and internal resistance. Similarly, current flowing through the second cell, potential remains same. So I2 is E2 minus V divided by R2. So this is the current which flows through the second cell. Now I know main current is I1 plus I2. So substituting for I1, E1 minus V by R1 plus substituting for I2, E2 minus V by R2, or I split the denominator to make simplification easy. E1 by R1 minus V by R1. I am just splitting the denominator in terms of E and V. So E by R1 minus V by R1 plus E by R2 minus V by R2 to make calculation simple. Now I put all EMFs together, internal resistance together. So E by R1 plus E2 by R2, they form a single term, minus V 1 by R1 plus 1 by R2. All EMFs together, internal resistance together. Taking LCM, E1 R2 plus E2 R1, cross multiply, E1 R2 plus E2 R1 divided by R1 by R2 minus V R1 plus R2 divided by R1 R2. Again, I repeat this simplification. I take LCM R1 R2, hence cross multiply E1 R2 plus E2 R1 minus V R1 plus R2 divided by R1 R2. Now I want potential. I need to compare potential. So on simplification, V is E1 R2 plus E2 R1. R1 R2 gets cancelled. Minus I R1 R2 divided by R1 plus R2, framing equation 1. Now students, again I replace those two cells in parallel by an equivalent cell. A equivalent cell ಏನು ಮಾಡಬೇಕು? It should draw the same current under the same potential. So for that equivalent cell, again V equals EQ minus I R EQ. Compare equations 1 and 2. Equivalent EMF is given by E1 R2 plus E2 R1 divided by R1 plus R2, and this is what gives me equivalent internal resistance. Now dear students, again this is the same form for two resistors connected in parallel, hence establishing the parallel nature of the cells. So in today's session, we have clearly understood the expressions for equivalent EMF and equivalent internal resistance. when two cells are connected in series and parallel. Hope you work it out. Be thorough with the derivations. The parallel derivation is very important for 5 marks. The next session, I come up with a very beautiful topic called Kirchhoff's laws of network. Until then, stay safe. Thank you.